Good morning, everyone. You are my favorite student. My name is Yohana Mahamat Abderasul. We are here to present our project about the generative AI framework for encoding and generating moral narratives from traditional knowledge. To put it simply, we are building MORALROOTS AI. Our goal is to solve a major problem in modern technology. The fact that most AI models today are biased toward Western stories and values. Our research focuses on how we can use machine learning to encode the rich oral traditions of Uganda, Chad, and DRC, turning ancestral wisdom into a digital elder that can teach our children their own cultural morals through technologies. Here is our content of presentation. Then here is the background and introduction. Our research addresses a major gap in modern technology. While AI is powerful, it suffers from a Western bias. In our region, Uganda, Chad, and DRC, we have centuries of moral wisdom stored in oral traditions. Our project, MORALROOTS AI, creates a way for AI to learn these specific values so that when it tells a story to an African child, it sounds like a digital elder, not a foreign computer. Here is our related works. In the academic world, most work focuses on English. However, groups like Masakan and Google Research with the Worksoil dataset have started to digitize African languages. Our work takes this is a step feature. We are not just looking at translation, we are looking at moral alignment, ensuring that the AI understands the ethic behind the word. Then here you have the problem statement. Now we want to define the core problem our research solves. Today, if a child in Uganda or Chad asks an AI for a story about honesty, the AI often provides a story set in a Western context with Western values. This is what we call Western narrative bias. The problem is that our AI models do not have a moral source code for our region. Without this, we are losing our oral tradition to a digital first world. Our research addresses this gap by creating a way for machines to understand our ethics. Here you have research questions and objectives. To solve this problem, you are focusing on two main research questions. First, can we turn ancestral wisdom into math? And second, does this actually make the AI story feel more authentic? To ensure this, our objectives are clear. We are extracting a structured ontology from 6,500 stories using PCA to map these values into embedded vectors, and finally fine-tuning a llama model. This ensures that the generative output isn't just a story, but a cultural correct lesson for children aged from 5 to 13. In our research contributions, this work makes three key contributions. First, we have built a pipeline to extract moral from oral stories. Second, we created a feature engineering framework that identifies cultural markers. And third, we use PCA to mathematically visualize how different cultures share on or differ in their moral values. Then you have the methodologies and the system architecture. Our system architecture is a clean 4-stage pipeline. We take raw narratives, clean them, and then perform vectors analysis. By using PCA, we can find the index of maximum similarity between, for example, a Baganda story and a Chajan fable. This ensures the fine-tuned llama model generates text that is cultural conditioning. Then here you have the dataset description. To ensure academic integrity, we avoided generating cargo datasets. We synthesized the MORALROOTS Central Africa dataset of 6,500 stories from primary research sources. And each story is tagged with its culture, target age group from 5 to 13, and a specific moral category like respect or honesty. This is the gold standard data we use for training.
Hello everyone, my name is Okot Victor, and I'm continuing from where my member stopped from. So we are going to start from data description and exploratory data analysis. For this case, when we talk about the dataset we are using, it was a core corpus. Our dataset consists of 6,500 entries we got. Then the primary source is the consolidation of Ugandan oral traditions, for example, the Baganda, Acholi, the Ankoli, and the cross-African traditions. The target variables, we have the features specifically engineered for moral alignment, explicit moral category, and moral type. Then the computation goal, it is to create the first structured master data frame that integrates the culture metadata and the narrative text. After loading and cleaning our dataset within the EDA, we shall provide some visualization with explanations to make our project more understandable. This is one of the visualization we made, the output results and the discussions. This one is showing how we are integrating unsupervised learning in our project. And for this case, the visualization, this is the accumulation of our work. It projects the high dimensional story space down to a 2D using the PCA, and then colors the points based on our weak supervision signals. As you can see on plot 1, it uses a cool warm color map to show the sentiment. We can see a visible separation with the blue, which is the positive, and the red, which is the negative points, forming distinct regions. Then when you look at plot 2, it is a positive outcomes. It highlights stories with positive outcomes in green against a gray background. Then they appear to be a cluster in the lower half of the plot. Then the plot 3, it is the negative outcome, which highlights stories with the negative outcomes in red. Then they appear to cluster more in the upper half. Then when you look at plot number 4, it is the community versus tradition. This one uses distinct colors to show stories flagged for community themes versus traditional themes. This also shows a degree of separation. Now, how does this one help us? The fact that we see the fact that these weak signals created using simple heuristics show a natural separation in the PCA space, it is a powerful validation. Then it confirms that the embedding space is not a random noise. It is structured in a way that aligns with the meaningful story features that's like sentiments and thematic content. This structure is exactly what we leverage in the next stages of our project to build our culture generative model. These are the tabulation of the results, as you can see from here. Then when you go to our next, it is we can see the PCA projections with weak supervision signals. These ones, the purpose, it is to determine the intrinsic dimensionality of the dataset. Then these plots will help us to decide how many principal components are needed to capture the most significant patterns in the text embeddings. Then the key findings to this, the analysis will identify a distinct or a knee point or an elbow at two components. Then this suggests that the most significant variance in the moral narrative data can be represented in simplified or a two-dimensional space. Then what is the technical insight of this data? The accompanying text explains that while the intrinsic dimensionality is approximately 2, capturing most of the variance requires more components. Specifically, 80% of the variance is captured by 15 components and 90% by 21. This is a classical result in the text analysis. The core structure is a low dimension. Iggy, when you look at the main moral dimensions, but capturing the nuisance of language requires many more, as we are going to be exploring our data. Now, when you look at the k-means clustering results, when you're clustering our results, we see that the visualization shows that our 100 moral stories naturally group into 5 distinct clusters when analyzed in embedding space. The left graph are stories with similar moral patterns, they are clustered together. Then the separation along the PCA, the PC1, which is the horizontal, suggests that a positive or a negative outcome dimension, while the PC2 separates individual versus community focused stories. The middle graph, when you look at it, the X markers, they are the cluster centers or the prototypes that we are going to be looking at. Their spread confirms these 5 archetypes are meaningfully different. Then the right graph clusters the sizes, show the distribution, the 35 stories, the 28 stories, the 18 stories, 12 stories, and 7 stories. They're all collective punishment tales. Then we have the community reward stories, the individual moral journeys. All of this, it is brought up in order to help us get what? The morals, to identify the morals behind which we can use to train our model such that it can help to reach our goal for this project. When you look at this, now this is the cluster characterization of our what? Of our results. Cluster 0, it is 932 stories. It is slightly a negative sentiment, which is a 34 with a 34 positive outcome and a 24 community focus. When you look at the cluster 1, they are 1,832 stories, slightly negative, with a 27 positive and a 29 community largest cluster. When you look at our cluster 2, they are 947 stories, slightly negative. When you look, it is slightly negative. Cluster 3, 1,734, we are having more negatives. Then cluster 4, most negative. What are the insights to this? We are seeing that clusters with more negative sentiment actually have higher positive outcome percentages. What does this help us? It shows that in the communities where there are a lot of moral negative outcomes in the moral, it is showing that when we try to put our stories from our generative AI, it will give us a positive outcome and suggesting these are redemption stories. So we shall have a negative journey to a positive resolution. So clusters with strong what? With a stronger Okay, now onto the next, it is the Gaussian mixture models. So for this, we are seeing that the left graph shows the 5 components is optimal, confirming our k is equal to 5, which means the k-means is statistically sound. The middle graph shows the soft clustering, where each story has probability of belonging to multiple clusters. Colors represent the colors are representing different mixture components, revealing overlapping moral categories rather than hard boundaries. When you look at the right graph, same story. Then the key insights: moral categories are not always discrete. Some stories blend multiple moral values, low confidence points. This suggests that the generative model should have moral mixtures, not just pure categories. When you look at this, we are looking at the story length patterns. This one, what does it help us? We are going to see that stories between 180 to 200 words, they are mixed sentiments. Then those of 45 to 80, they are more extreme sentiments. So for such stories, story length correlates with moral complexity, not sentiment. But for short stories, they deliver quick moral punches, while longer stories develop a nuanced moral situation. So the model should adjust length based on the age group, not on the moral valency. Now, when we come to the conclusion of our presentation, so successful encoding, we demonstrated that African moral ontologies can be mapped into high-dimensional embedding spaces. Then when you look at the regional overlap, unsupervised clustering revealed a shared moral core across Uganda, Chad, and DRC. Then for the generational accuracy, culture or conditioned fine-tuning significantly reduces Western narrative bias in generative stories. Then the impacts, the framework serves as a digital elder, bridging the gap between traditional oral wisdom and modern education technologies. What are the limitations we found? It is the nuisance laws. AI may struggle with deep metaphors and historics, oral secrets. Then the model hallucination, risk of the AI mixing cultural protocols, e.g. the Chadian rules in the Ugandan story. Then the technical access, high computational cost of the Llama modules in rural regions. But all of this, I think our module can at least try to come to solve this. Then the next steps, what we are going to be doing, we are going to be a multimodal narrative expanding from text to AI generated audio and visual art in indigenous styles. We are going to have an RILCF implementation. This is introducing the reinforcement learning from child feedback to refine moral age and approximateness. A direct expansion, scaling the framework to include more Saharan and Great Lakes from Congo, local dialects. Then the mobile deployment, developing a low bandwidth offline application for rural education access. So, thank you for your listening. So, the acknowledgement, we would like to express our sincere gratitude to our supervisor and anyone who's contributed for their invaluable technical guidance and providing the datasets that made this work possible. We look forward to everything. Thank you. Sign out. Peace.